All right, finishing up that question now. I had to switch it, so let me see if I can get into my other window. So I switched it so I could type out something. So, and all the information it was on review 3.5. So they tell us to find the equation for the appropriate least squares regression line for Professor Friedman's prediction. Now, in this problem, they don't give you data, but they give you some statistics about the situation. So back on page 183 of the book, it had an equation. So it's y equals a plus bx, okay, or y equals mx plus b, however you want to read that. But so in the more recent versions of math, they'll write y equals a plus bx, where b is our slope, and we can find the slope from this equation by taking r, which is the correlation, times the standard deviation of your y values divided by the standard deviation of your x values. So if we read through that problem up there, it said, now remember that the y is your response variable and the x is your explanatory variable. So in this case, it's going to be your scores before the final are your explanatory. The scores after are the response. So it's set up above the pre-test scores had an average of 280 when I added all those up with a standard deviation of 30. Okay, the final exam had an average of 75 with the standard deviation of 8. Okay. That student had a 300, and we want to try and get the equation of the line so we can predict what their final would be. So I'm just going to plug stuff into this equation. So my slope is going to be 0.6, which is the correlation, divided by the standard deviation of y, which they told us in the problem was 8, and the standard deviation of x, which is 30. So 0.6 times 8 divided by 30 is 0.16. Then to find your y-intercept, your a, you take y bar, the average of y's, minus b times x bar. So I'm just plugging in those numbers. So 75 minus that 0.16 that we just got for b times 280, which is x bar. So we get a equals 75 minus 44.8, or a equals 30.2. So my equation ends up being the final exam equals 30.2 plus 0.16 times my pre-exam total. So then I plug the 300 that she had for a pre-exam total in for x, and I get 30.2 plus 0.16 times 300. So her prediction for her test would be a 78.2. That's how you go about doing 3.5.